Now I will start the discussion of this particular problem, which is based on the maximum power transfer theorem. We first convert the given complicated network into the Thevenin's network and then apply the maximum power transfer theorem. This maximum power transfer theorem is applicable to those circuit which has this structure. Is it right? This may be ZL or this may be the RL. This is RS and this is the source, whatever VS. Is first we have to convert into this, and this value will be same as this for maximum power transfer theorem if it is resistive. Otherwise, it is complex conjugate if it is impedance. Is it right? So first what we will do, we will convert this network into the Thevenin's network, then we will find out the RL and then we will find out the maximum power which is transferred to the load in this particular case. Is it right? So here in this case what I am trying to do, I will read the problem, calculate the value of the load resistance for maximum power transfer. If we want to find out the value of load, we must know the source impedance or source resistance. That's why we will convert this complicated network into the Thevenin's equivalent network first. I will write the same. First, we will find out Thevenin's equivalent network for the network shown above. Finding Thevenin's equivalent network for the complicated network shown above. Is it right? This is the first step. Now for this case, what we will do, first we will remove the load resistance and then we will apply the Thevenin's theorem procedure. The first point in this case, removing the load resistance and redrawing the same circuit, we get removing RL and redrawing the same figure. Is it right? How will be the figure? I will draw here. Just we are removing the load resistance and we are drawing the same figure, and here we are interested in the calculation of VTH and RTH. This is the case. This will be the figure. Is it right? This is A point and this is B point. In this case, this is the 3 volt, it is the 6 ohm, this is again 6 ohm, this is again 6 ohm, and here this value is the 12 volt which is plus and minus. This is 3 volt which is plus and minus again. Is it right? Now apply any method and just calculate the voltage between these two terminals, which is nothing but the VTH. Here for the calculation of VTH, we will use the mesh analysis here. This is the loop 1, its current is I1, this is the loop 2, its current is I2. This is again plus minus, this is plus I minus, or this may be the plus minus. Otherwise you can use any method, maybe the nodal analysis. In that particular case, how many nodes we have? This is one branch, this is second branch, this is third branch. Means we have, it is 2 nodes only. Is it right? This may be the ground node and this may be the node 1, and we can find out its value. Otherwise we can use a direct inspection method. But for simplicity, because we are starting with the first problem, that's why here I'm using the mesh analysis. I will write here first, applying the KVL to the first loop. Applying KVL to first loop. We will apply the KVL or Kirchhoff's voltage law to the first loop and we will prepare its equation. If we are starting from this point for the loop 1, we are traveling in the clockwise direction, negative to positive, that is a plus 12, then positive to negative for this resistance, positive to negative, it is a minus 6 into its current, which is I1, then positive to negative, it is a minus, its resistance is a 6 and its current is I1 minus I2, which is equal to 0. This is the equation. Simplify this equation and name this equation as equation number 1. This is 12 minus 6I1 minus 6I1, then minus up minus plus, it is 6 into I2, which is equal to 0. This is the equation. I will simplify it further. This is 6 and 6 means it is minus 12I1. It is minus 12I1. Then it is a plus 6I2, which is equal to minus 12. This is the equation number 1, which is for the first loop. Because we are interested in the calculation of current in this branch. Because we are interested in VTH. Similarly, we will apply the KVL to the loop 2. I will write the same here. Applying KVL to loop 2. We will apply the KVL to the second loop. If we are applying the KVL to the second loop and if we are starting from this point, we are traveling in the clockwise direction. Positive to negative, it is a minus 6 into its current, which is I2. Then positive to negative, it is a minus 6 into its current, and its current in this case is I2 minus I1. And finally, positive to negative minus 3, which is equal to 0. This is the application of the KVL. If we know this equation, we will simplify it. It is minus 6 into I2, then minus it is 6 into I2 again, then minus up minus plus it is 6 into I1, which is again minus 3, finally, which is equal to 0. In this case, equation will be, it is plus 6I1 minus 12I2, which is equal to plus 3, and this is the equation number 2. Now, in this case, we have the two equations and the two unknowns. Solve both equations and find out its value. Solving equation number 1 and 2. We will get the I1 and I2. Now find out the values of the currents, which is I1 and I2. In this case, we are more interested in I1 rather than I2 because we will use this path. In that case, this potential is already known. We want to find out this potential, means we are interested in the I1. Yes, I'm expecting the answers from your side. Solve these two equations and find out the values of the currents I1 and I2 in this case. Yes. Yes, Saurabh. Unmute yourself. Yeah.
The I1 value 1.16.
1.16 amperes and I2 is
0.33.
0.33 amperes. If we know the currents I1 and I2, now we are in a position to find out its VTH. Now, this VTH is equal to, how much is the Thevenin's equivalent voltage? This VTH is equal to, we are traveling from this B point towards A. If we are traveling from this B point towards A, in that case, this VTH is a modulus value. We are traveling from the negative to positive plus, its voltage is 3. The negative to positive, which is a plus, its resistance is 6 and its current is I1, which is 1.16. Simplify this equation or find out this value, which is the VTH. Yes. How much is the value? Anyone? Unmute yourself. Yes, Saurabh.
9.96.
This VTH is equal to 9.96. Is it right?
Yes, sir.
9.96 volt is the value of VTH. If we know the value of the VTH, then next we will find out the value of the RTH. Is it right? First we will convert the given complicated network into the Thevenin's network and then we will apply the maximum power transfer. So here next we are interested in the calculation of the RTH. I will write the similar points. For the calculation of RTH, RL is removed and all sources are replaced by respective internal resistances. internal resistances. How will be the figure in this case? If we are working on this is the voltage source replaced by zero resistance. This is voltage source replaced by the zero resistance. In that case, this will be the figure for the calculation of RTH. Here is the point A. This is the point B. It is 6 ohm. This is 6 ohm, and this is also 6 ohm. So work out this series and parallel combination and find out its value. Right. So here in this case, this is the wire. I can shift this point here, as well as I can shift this point here. If we are shifting this point here, that A will be on this side. How will be the figure? A will be on this side. This will be the 6, upper 6. I am drawing first. This is upper 6. Then this is the 6. Is it right? This point is, I am treating it as a B point. This is, I am treating it as B point. Because both are same. I am shifting this point here. And this resistance is, one is at A point. If I am treating it as A point, and this is as a B point, otherwise I will give the different name. This is C point and this is D point. In that case, this will become C point because I am shifting here, and this is C point, and this will become A point because I am shifting here. This is C and this will be the A. This will be the D. I am shifting here and this will be the B. Means this is D and this point will be the B point. In that case, this resistance will be connected between C and D. Here is the C point and here is the D point. Means something like this. It is 6 ohm, this is 6 ohm, and this is also 6 ohm. So here in this case, if we know these values, then we are in a position to find out its value of the RTH. Is it right? We are in a position to find out its value of the RTH. How will be the calculation? I will use the formula. 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus it is 1 upon R3, which is equal to 1 upon 6 plus 1 upon 6 plus 1 upon 6. This value, make it reciprocal and then find out its R. First find out 1 upon R, this value. How much is this value? If we have the two resistances only, then we will use the formula R1 into R2 divided by R1 plus R2. Otherwise, this formula will be the simple. How much is the value of 1 upon R?
Point 5.
This is 0.5. This is 0.5 ohm. It's reciprocal, 1 upon 0.5. I guess its value is 2 ohm is the RTH. This is RTH. This is RTH. Is it right? Now, if we know the VTH and RTH, then this complicated network will be replaced by the Thevenin's equivalent network, and then we will apply the maximum power transfer theorem. Is it right? You see here, first I will draw the Thevenin's equivalent network. In this case, this is the Thevenin's equivalent network. And load resistance is RL. And we are interested in the calculation of this value of RL. This is 2 ohm. And its value of the VTH. Its value of the VTH is found to be 9.96. It is 9.96 volt is the value of the VTH. Is it right? Now I will write here, as per maximum power transfer theorem, what we have? We have RL is equal to RS, which is equal to 2 ohm. This is right. This is 2 ohm. Now now we have calculated the RL, but what is the problem? The original problem was find out the load resistance for maximum power transfer, also calculate the maximum power transfer to the load. First we have to find out its current. With this value of RL, now I will find out its load current, that is IL. Now here IL is equal to, what is the formula for calculation of the current using the Thevenin's theorem? If we are interested in the calculation of this load current IL, now this IL is equal to VTH which is 9.96 divided by RTH plus RL, that is 2 plus 2. Find out this value of the current, which is nothing but the load current in this case. How much is the value? Yes.
2.49.
This is 2.49 amperes is the value of the load current. If we know the load current, therefore Pmax, that is maximum power transferred to the load, in this case will be IL square into RL, which is equal to 2.49 its square into RL is the 2. This RL is not 2 plus 2, but it is only the 2, and find out this power, which is nothing but the maximum power transferred to the load using this particular theorem.
12.40.
12.40 watt is the Pmax, that is maximum power transferred to the load.